Hello everyone, my name is Shashank. We are presenting solutions for JEE Advanced 2019, Paper 1. The question for this video is taken from the chapter Application of Derivative as in the paper. Let's have a look at the problem. Let f r2r be given by fx is equal to x raised power 5 plus 5x raised power 4 plus 10x cube plus 10x squared plus 3x plus 1. It looks like the opening of x plus 1 whole raised to the power 5, isn't it? 5c1, 5c2, 10 is 5c2 now. But the term coefficient of x is like creating problem. If it would have been 5x, then it is directly the opening of x plus 1 whole raised power 5. So we can, however, write it as x plus 1 whole raised power 5 minus 2x. 3x can be written as 5x minus 2x. Let's see how can we take help of this thing here. For x less than 0, it was defined as this. For x 0 to 0 close to 1 open, it is x square minus x plus 1. For 1 close to 3, it is 2 by 3 x cube minus 4x square plus 7x minus 8 by 3. And for x greater than or equal to 3, it is x minus 2 log of x minus 2 to the base e minus x plus 10 by 3. Which of the following options are correct? Option A, f is increasing in minus infinity to 0. F dash has a local maximum at x equal to 1. So we need to check f double dash also. Because in order to check the points of local maximum minima of some function, we need to find its first derivative. So the derivative of f dash would be f double dash now. So we need to go to f double dash, up to f double dash. F is on to option C. So whether the range is R or not, because the codomain given is R. So we need to check that. F dash is not differentiable at x equal to 1. Okay. So this will also be retrieve using the second derivative, values of second derivative. Let's see how can we solve this question. Okay, the question looks lengthy, but I'll try to make easy for you. Let's see. So fx is this. So if you write 3x as 5x minus 2x, and by taking 5x, f dash can be written as 5, because it is x plus 1 whole raised power 5 minus 2x. Derivative is 5x x plus 1 whole raised power 4 minus 2, x less than 0. For 0 to 1 it is 2x minus 1. We are not applying equality over here, at 0. We'll check it first. At 0, in the left of 0, at 0 minus, the value is 5 minus 2, that is 3. In the right, it is minus 1. So they're not matching. So we should not apply equality here. We cannot carry 0 equality here as was given in fx, because obviously here the function fx would be not differentiable at x equal to 0. So we cannot take 0 in the domain of f dash, isn't it? Next is third piece, third interval. It is 2x square minus 8x plus 7, and at 1 minus the value is 2 minus 1 1, and 1 plus it is 2 plus 7 9 minus 8 1. So at 1 it is differentiable. So it's like this, and for x greater than or equal to 3, we need to differentiate x minus 2 ln of x minus 2. So it would be x minus 2 into 1 by x minus 2 is 1, and minus x derivative is minus 1, got cancelled, and one more part will come as ln of so log x minus 2 to the base e, the final derivative for the last part. And x at x equal to 3 it is 0. At x equal to 3, the above part is 9 into 2 18 plus 7 is 25 minus 24 is 1. So x greater than 3, we can write. We should not carry 3 here also, equality sign. because at 3 yeah uh, the at 3 minus and at 3 plus the values are different, right? So now we can say, now coming to the option A, f is increasing in minus infinity to 0. So is it increasing in the first part? So we can easily see that the first derivative derivative in the first interval minus infinity to 0 is not always positive or not always negative. So this part is not always positive. So f dash is changing sign from minus infinity to 0. It may be negative, may be positive, can change sign in minus infinity to 0. So we can say that the option A is not correct, right? It is not always increasing, always positive. F dash was not always positive. F is on to, f dash has local maxima, f dash is not differentiable at x equal to 1. So let's see. F is differentiable at x equal to 1. But when you find f dash, so f double dash 1 minus would be 2. However, f double dash 1 plus would be 4 into 1 minus 8, that is minus 4. So it is they're not matching, right? So f double dash f dash is not differentiable because the LSD for f dash is 2 and RSD for f dash is minus 4. So LSD is not equal to RSD. F dash x function is not differentiable at x equal to 1. And again from here we can easily see that the change of sign of the derivative of f dash, that is f double dash, the change of sign of f double dash from the left of 1 to the right of 1 is positive to negative. So it must be there will be a sharp S. As far as the graph of f dash is concerned, there will be a sharp S. Function f dash is not differentiable at x equal to 1, but it will show a point of local maxima at x equal to 1, because in the left of 1 it is positive, in the right LSD is positive, RSD is negative. Right. At x equal to 1, f dash was continuous, but f dash is not differentiable. There would be a sharp corner, the point of local maxima at x equal to 1. Coming back to the options, option B would be correct. F dash has a local maxima at x equal to 1. F dash is not differentiable at x equal to 1. I think I clearly described it. Yeah. And coming to the option C, f is on to. Yeah. So what we can say about the range of fx? Is it R or not? Okay. The major part of the values of y is coming from the first and the fourth intervals. If you observe, in the fourth interval, like for x greater than or equal to 3, the derivative is always positive. Log of x minus 2 to the base e is more than 1, base is more than 1. And for x greater than 3, log of x minus 2 is always more than log 1, means more than 0. So this part is increasing, right? So in this part the range would be, just by putting x equal to 3 here, it will give you 0, and here from here you'll get minus 3 plus 10 by 3, that is 1 by 3. So in this part we can see that y is from minus 3 plus 10 by 3 is minus 3 plus 10 by 3, 1 by 3 to infinity. And in the first part we can see as function however is not strictly increasing fx, but by intermediate value property, as it is an odd degree polynomial. At minus infinity the value is minus infinity. I'm just saying the end points. At 0 the value is 1, isn't it? So I mean the minimum, the values, we can say by intermediate value property fx will take all values between fa and fb. So all values between minus infinity to 1. That is to be sure, at least once. However, it will take, in this case, if you closely observe it, few more values apart from this interval. But this is to be sure that minimum it is taking from minus infinity to 1. From these two only we can say that the union of these two intervals of what y is taking here is r is minus infinity to infinity. There is some overlapping from 1/3 to 1, but the range from here we can clearly say that the range of y is minus infinity to infinity. That is to be sure. Coming back to the option C must be correct. F must be onto because the codomain is also, range r, then function is onto. I hope you understood the solution. You may go through the typed, so B, C, D were correct. Typed solution also is there. You can go through it. Yeah, stay tuned for the next question. Thank you.